We apply the sum rule to tasks that are mutually exclusive. So say I can break a particular procedure down into 3 tasks. So we have task 1, we have task 2, and we have task 3. If they are mutually exclusive, I can think of using the word or. If I can do 1 or 2 or 3, then we use the sum rule. So we would say task 1 plus task 2 plus task 3 is going to give me the total number of ways to complete the procedure. Think of it for just a minute as if you were sitting at your house and you had several options that are available to you. First, you could go to school. I'd say that you could decide to drive to school and do some homework. Let's say that you could go to work and you could get some money for working, or you could go to the gym and you could lose 3 pounds. And let's say that when you look at Google Maps, you say that there are actually 3 different ways that you can get to school. There are 6 different ways that you could get to work. And from your house, there are only 2 ways that you can drive to the gym. And so, given the fact that these are mutually exclusive tasks, I would add them together. 3 plus 6 plus 2 is going to give me 11. So another example might be that you get a new debit card from your bank and they say, I want you to pick a number, a PIN number. And the PIN can be 3, 4, or 5 digits in length. How am I going to decide what are the total number of different PIN numbers that we can have? For this example, task 1 is going to be 3 digits in length. Task number 2 is going to be a PIN with 4 digits in length. And task number 3 is going to be a PIN with 5 digits in length. So, if I have 3 digits, I have to decide how many different permutations of that I can have. Well, if they are digits, then I can have 10, 10, and 10. That is going to give me 10 raised to the 3rd. If I follow that same algorithm, this is also going to give me 10. So this would be 10 to the 4th, and then I can only guess that this would be 10 to the 5th. And so once I've come up with those numbers, calculated those numbers, what am I going to do with the 3 of them? And we're going to find out that because my PIN can be 3 or 4 or 5, I can choose between each one of those 3 independent tasks. I would actually add them together. So this is going to give me 1,000 plus 10,000 plus 100,000, which will ultimately equal 111,000. And so I use the sum rule when I am faced with tasks where they're mutually exclusive. I can do one or the other or the other. So where the sum rule involves mutually exclusive tasks, the product rule involves one or more tasks that have to be completed together. So let's go back just a minute to the idea that you are sitting at home, and in order to get to school, there are 3 different routes to get to school. In order to get to work, there are 6 different routes to get to work, and to get to the gym, there are 2 different routes to get to the gym. Let's say, for instance, instead of deciding whether or not you're going to go to school or work or gym and see how many total different routes there are, let's say, for instance, that you have to go to school, and then from there, you're going to go to work, and then from there, you're going to go to the gym. Now the question is, how many different routes are available to me? So my analogy is breaking down a little bit, because it says there are 3 different routes to get to school. There are 6 different routes to get. Let's pretend for a minute that those are routes from school to work. And then let's pretend that the 2 routes are from work to the gym. Because you have to go to school, and then you have to go to work, and then you have to go to the gym, I'm actually going to multiply these values together. 3 times 6 times 2. And that equals 36. And so the use of the word, when I hear the word and, that would indicate to me that all of the tasks must be completed. Maybe not in that particular order, but they all must be completed together. And this is when I would apply the product rule. In the sum rule, they are mutually exclusive. I can do one of them, or I don't have to do all of them. I can just choose to do one of them. So let's do an example of this. So let's go back to your bank, and your bank now tells you that they have to have a PIN, and that your PIN has to be 5 characters long, and that the first 3 characters are going to be lowercase letters, and the second two characters are going to be numbers between 1 and 5. So now we have to decide how many different pins can I have based upon that criteria. And so I'm going to lay it out here in front of me. There are 5 digits in the pin number. The first 3 characters have to be lowercase letters. Well, there are 26 lowercase letters, so I'm going to put the 26 here. And then the last 2 have to be character numbers between 1 and 5. That would give me 5 options for this one and 5 options for this one. And so I'm going to use the product rule because the pin must be 5 characters long. That means that I have to choose a first character first, and a second, and a third, and a fourth, and a fifth. I must do all of them together or at the same time. And this is going to give me 26 cubed multiplied by 5 squared, which equals 439,400. So there are 439,400 different ways that I can select my 5 character pin number. And we use the product rule because all 5 of the characters must be chosen. You may not have been paying attention when we were doing the sum rule, but we actually applied the product rule and the sum rule together at the same time. When I presented you the problem that said that your bank told you that you can have a pin that is 3, 4, or 5 digits long, and we were trying to evaluate how to calculate task 1, which included 3 digits, and I said that if there are 3 characters long and each one of the characters can contain digits, I said that it would be 10 for the first one and 10 for the second one, and we just naturally applied the product rule by multiplying those 3 values together. We repeated the same process for task 2 when I had 4 digits. It just seemed natural that if each one of the 4 digits could contain 10 characters, that I would multiply them together and get 10 to the 4th. And we applied the same thing as 10 to the 5th. So this turned out to be the product rule that we applied as we were attempting to find out the number of characters or the number of distinct combinations that I could have for each one of the pin numbers. And then we applied the sum rule when we added the 3 different tasks together. Most of the time, the story problem that you're presented with or the math problem that you have to solve may not explicitly use the words and or, and sometimes you just have to work it out. But the idea is that if I have tasks that have to be completed, all of them must be completed. I am dealing with the product rule. But if I have tasks that I can choose between them, I'm dealing with the sum rule.